understand what is going on, and it requires you to have memorized cube roots. Since most of you have not memorized the cube roots, I will proceed to do this the long way. 80 breaks down into 8 and 10. Now, I can stop there because I know 8 has a cube root. But some of you don't know that, so you would continue to break it down. 2 and 4, 2 and 2, 2 and 5. There is a group of 3, and there is not, which means that group of 3 comes out to the front. What's already there? 5. What do you do with them? You multiply them together to get 10. And then, what did you leave under the radical sign as a radicand? 2 times 5, which is 10. And how do we read that? 10 cube root 10. That's how you would read that. Yeah? Yeah. Now, in 3, I have asked for a cube root again of a number, letter, and letter. You already know how to do the cubed root of a number. 108, and you break it down. It's 27 times 4. I'm stopping there. Why? Because 27 has a cube root. What is it? 3. So out comes a 3. Leaving 4 under there. So I have 4 under the radical sign. How many groups of 3A's can I get out of there? A cubed means I have A. Is that a group of 3? So can I take it out? So also coming out to the front is an A. I also have 5 B's. Can I get out a group of 3? It'll show up in a second. Yes, I can. So what else is coming out to the front? A B. What did I leave under there? B. Would a math guy ever write BB? What would a math guy write? B squared. What's out front? 3, 7AB. What do you do with all those? Multiply them together. 21AB. Done. Does anybody need further instruction on simplifying radicals? If you do, make a small note to yourself, because we will be doing review today. And when I say work, you will want to say, Myers, I need a little bit extra on that. Okay? Okay. Move on to this one. I am now multiplying radicals. The example I used to multiply radicals was the same as what we do with variables that you already learned in the 9th grade. Michael?
You read dad jokes Thursday?
Yes, I do, but they're all knock-knock jokes. I went with knock-knock jokes today. Weird.
Like, it's time for jokes?
Huh. Knock, knock.
Who's there?
Shelby.
Shelby who?
Shelby coming round the mountain when she comes. Knock, knock.
Who's there?
Atch. Gesundheit. Knock, knock. Boo. Stop crying, Aiden. They're just knock-knock jokes. Yam, 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 yam. What?
That's a throwback to 4th grade.
Knock-knock jokes are always solid. In the honors class, they asked about dad jokes, and I said, I'm doing knock-knock jokes. And then one of the kids said, oh, knock-knock. And I said, who's there? And he says, wait a minute, aren't you telling the jokes? I said, but you said knock-knock. And he said, no, you. It was pretty funny. You had to be there. I think I recorded it, though. All right, back to business. Unless anybody else has a knock-knock joke, because today is knock-knock joke dad Thursday. No? I know interrupting cow. Nobody else? Knock-knock?
Who's there?
Cantaloupe.
Cantaloupe.
Cantaloupe with you tonight. Dad's got the ladder.
Wow.
And of course, orange.
No.
I love that one. That one never gets tired.
I'm not sure if anyone
Cantaloupe. If you can't elope, because Dad's got his ladder. I can't climb up to your room and steal you away. All right, let's go. So, this one. Now, the example is this. What do you do if I ask you to multiply that? You put the numbers together and the variables together. Same thing here, except if I were to do that, I would have to do 27 times 45 and then simplify that. That's a stupid big number. So what should I do first? Simplify now. That's 9 times 3, right? Why did I use 9? Perfect square. What's coming out? 3. 3 times 3 is 9 root 3. That's 9 times 5. What's coming out? 3. 24 root 5. Now, 9 times 24 is much easier. 9 times 20 is 180. 9 times 4 is 36. 180 and 36 is 216 root 15. Can I simplify 15? No, because it's 3 and 5. There's no pairs. Done. What about this one? Well, again, if you remember what you know from grade 9, 3x bracket 2y plus 3z, you would know that everything goes to everything. And you multiply them all together, except 6 times 72 is a big number. So what should you do? Simplify first. 2 root 6 doesn't simplify. But 72 is 36 times 2. 36 has a square root. What is it? 6. So out there I get 12 root 2. 8 is 4 times 2. Out comes a 2 plus 2 root 2. Oh, look, I got 12 root 2s and 2 root 2s. Oh, right. 12 root 2 and 6 root 2s. How many root 2s do I have? 18 root 2s. Now I can multiply. 2 times 18, 36. 6 times 2, 12. Can I leave it like that? Why? Because that's 4 times 3. What comes out? 2. 72 root 3. Now, to do all of that work, how much math did you need to know? One thing, breaking down radicals, right? Because other than that, it's the only thing that was new this year. And you just keep breaking them down, and breaking them down. Yes.
Why were you able to bridging the 18 and root 2 from adding? I don't think
12 root 2s and 6 root 2s
Oh, okay. My bad.
are 18 root 2s. Just like 12 apples and 6 apples are 18 apples. Mrs. Bad Crumble knows her math. And finally, what we did yesterday. Where does that denominator go? To the index. Where does the base go? To the radicand. And the whole thing is to what power? 2. What is the 5th root of 32? 2. So that is 2 squared, which is what? 4. Done. This one. What do you got to do with those exponents? What do you do with exponents over brackets? Multiply. What's 1/3 times 2? It's not a trick question. 2/3. Where does the denominator go? 512, all squared. What is the cube root of 512? If you have it memorized, it's easy. If not, you got to break it down. What is it? He waited patiently.
8.
8. It's 8. 8 squared, which is what? 64. And finally, what do you have to here? Because this question, ladies and gentlemen, puts together everything we've done. Radicals, exponents, and rational exponents. Do they have the same base? Yes. What math is happening right there? Multiply. What do I do with the exponents when I multiply? Add them. 3 over 2 plus 2 over what? 1. How do you add that? No. They're fractions, dude. You need the same denominator, which is what, Ryan? 2. So it's 3 plus, that had to be times 2, so what does that have to be? So it's 3 plus 4. So it's 7 over 2, correct? So it is 16 to the 7 halves. Where does the 2 go? Index. Where does the 16 go? To the radicand, and all of that is to the 7th power. What is the square root of 16? 4 to the 7th. I can't do that in my head, so where do I have to go? 4, exponent button, 7. And what is it? It's a giant number. And don't read me the list of digits. Tell me what the number is. Now nobody wants to.
Hold up.
16,384.
That sounds about right. 16,384.
If you didn't want to do fraction stuff, you could just put down 16 squared and then done all the stuff with the 16 times.
Yep. You coulda.
It would have been technically a bit longer, but wouldn't have had to deal with fractions.
Yes, I know.
What did we do the other 16?
What? Yeah, because they're the same base, you can add the exponents, which I did right there. 3 halves plus 2 is 7 halves. So 16 was to the 7 halves. And then, what we did yesterday when you weren't here, we learned that the denominator becomes the index, and the numerator becomes the power. Okay, if everybody would be so kind as to turn in their books. Oh, I lie. I'm the worst kind of liar. Page 106. No, I'm not the Hamburglar. Robble. I wish the Hamburglar was still around. He was my favorite of those guys. Robble. Did anybody, you had the answers. Does anybody need to ask about anything from page 106? You know when you get those white sore things in your mouth? Any of you ever get those? Man, they hurt. I got one right here. Yeah, it's a canker sore. I got one right here. So every time I talk, my lower lip pushes against my gums and it hurts. Because usually when I say canker sore, people don't know what I mean. And then I say, you know those little white things that you get in your mouth? Oh yeah, canker sores. You're one of the first times that a kid has gone, you mean a canker sore? Nobody needs to ask about that. Everybody knows how to do it. What? 10D. As in donut. 0.75 to the 0.75. Yeah? Okay. So, Emily, I like to make these fractions. I find them easier to deal with. So that is 3 over 4, right? To the 3 over 4, right? Which means I need the 4th root of 3/4 to what power? 3. Done. That's it. Because the question says you just got to write it as a radical. Now, could you have left this as 0.75? Yeah. I didn't read the instructions, so I assumed we were going to be going further with it, so I changed it to a fraction. But when I look back and read the instruction, I didn't need to do that. So that could have stayed as 0.75. Pardon me? If I do what? Well, you would have left the 0.75 as 0.75, and that you need a numerator and a denominator. So you converted that to 3/4, because 0.75 is 3/4. Then you took the denominator and it became the index, and you took the numerator and it became the power. Everybody's good? All right, now listen please. That's good. Your next page should start with the instructions simplify without a calculator, yes? Excellent. And then you should have about 3 pages of work. Then you should have a textbook page. Is that the case? The textbook page is 233 in the psychedelic font. That is the case. And then you should have another textbook page that says 241. Yes? And then the next page should say review. Is that the case? Okay, so here's what we're going to do. Because what we are doing in this unit is so very, very important to next year's math, I give lots and lots of practice on it. So today we are going to be doing in your books pages 108 through to 110 in class. If we run out of time, we run out of time. It's no big deal. Is that an apple? Oh, okay. Never actually had one. I used to have an exchange student from China, and I didn't want to buy him an Asian pear for his lunch because I thought that would be, racist. So I asked him. I said, hey, Sean, do you like Asian pears? He says, what's an Asian pear? And relax.
You're offending.
No, relax. And then I go to the internet and I show him what an Asian pear looks like. And he says, oh, yes, we don't call those Asian pears. Well, because he's from Asia. I guess he just calls them pears. But he liked them and I bought them for him. I've still never tried one, though, because I do not like North American pears. I think they're disgusting.
You hate pears?
I hate pears.
You're not blessed.
I like trios. I hate pears, but I like trios. But no, I can't stand pears. I don't like them. I don't mind pear juice, but I don't like pears. They're all pulpy and grody. All right. Anyway, and then tomorrow you will do your review on this unit in class. We will mark it, and we will be testing on, what did I say? Tuesday. Yeah. So everybody go to page 108. Now, listen up. You have an option right now. I can shut up and let you work. That's fine with me. Just walk around and assist. Or I can do the first couple and we can see what happens. You guys want to just try it on your own? No. Go.